Hi, Year 7. Today we're talking about pi and the circumference of circles. Now, Archimedes, a very, very, very long time ago, was the first mathematician to discover that there was a relationship between the diameter of a circle, which is that length across the middle there, and the distance around or the perimeter of that circle. He found that all you had to do was multiply that diameter by a number that we call pi. Now, pi is close to 3, but it's not exactly 3. It's 3 with lots and lots and lots and lots. In fact, an infinite number of decimal places. And to use pi, we give it the symbol, this one. It's a Greek letter, pi, so it's basically like a T with a sloping top and 2 legs on it. Okay, so let's go through and fill in our blanks, and we'll talk about that some more. The diameter is the distance across the center of a circle. The radius is the distance from the center to the edge of the circle, which means that you would need 2 radiuses to be equal to 1 diameter. A chord is a line interval that connects 2 points on a circle. So for example, here's my circle over here. A chord goes from one side of the circle through to the other side of the circle. It doesn't need to go through the center. If it goes through the center, then we call it a diameter. So a chord is just a smaller length on one side of your circle there. A tangent is a chord that touches the circle at a point. And an interesting fact, so here is my circle. A tangent comes and touches the circle at one little point here. An interesting fact about that tangent, though, is that if you were to draw a radius here, the radius and that tangent always meet at a right angle. That's actually a property that you might learn more about when you do senior maths way, 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 way later on. But it's interesting. So next point, sector. A portion of a circle that is enclosed by 2 radii. Now, when you have a radius of a circle, we're talking about one of them, radius. The plural of radius is radii. Okay, interesting. It's not radiuses, we call it radii. So, here's my circle again. If I draw 2 radii coming out from the center, this section that is cut out there, which looks a bit like a piece of pizza, is called a sector. And the little bit of the side of the circle that you cut out, that little part in there, we call an arc. A segment is the area of a circle that is cut off by a chord. So back up here for my chord diagram, the segment is this bit of area that is cut off here. Now technically you have 2 segments. The smaller one we call the minor segment, and the big one we call the major segment. But we just need to know that that space is called a segment for now. We're not going to worry about the major and minor part too much. And finally we get to the part that we really want to focus on, which is the circumference. Now the circumference is the distance around a circle. In other words, it is the perimeter of a circle. It just has a special name because it's a circle. I guess it thinks that it can be special. So just think of circumference as being the perimeter of a circle. There are 2 formulas that we're going to be using for this. Now I've already talked about one of them, and that is that the circumference or the perimeter of a circle is pi, that magic number that I was talking about, times by the diameter of any circle. Now pi is a button on your calculator. Okay, you don't need to have it memorized, although that might be fun as well. To get pi on your calculator, you have to press the shift button and then this times 10 down here, and you see that it brings up the pi button. If I was to press equals, that's what pi is equal to, 3.141592654, and as I said, an infinite number of decimal places after that. There is no end to pi. It goes forever, those decimal places. Okay, so that's the first formula. C is equal to pi d. Now remember that we said the diameter is equal to 2 radiuses, so we could also change that formula to be C is equal to 2 pi r. Now that might be useful because some diagrams that you're going to be given, I'm going to tell you the radius, but in other questions I'm going to give you the diameter. So it makes it easier if you pick the right formula to use, depending on what the question is. So let's learn a little bit more about pi. So pi, as you'll notice, there's no E on the spelling of this pi. Pi, with this symbol here, is a constant numerical value, and it is an irrational number. Now we talked about irrational numbers at the beginning of the year. That just means that this number for pi cannot be expressed as a fraction. It is an infinite decimal that has no end, it has no repeating pattern to it, and it cannot be written as a fraction. As a decimal, the digits have no pattern and continue forever. The ratio of the circumference to the diameter of any circle is equal to pi. So this is pretty much how it was discovered, this number for pi. I mean, originally, they probably thought the value for pi was pretty much exactly 3. And they've gradually become more and more accurate and found that if you can measure the circumference of a circle and you divide it by the diameter of the circle, then you always get this same number, pi, the 3.14 blah, 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 going on forever. And if you're really, really accurate with that, then you get a very, very accurate measurement for pi. Okay, now before we start finding circumferences of things, let's practice labeling this circle with all those different words that I just introduced to you. So we have diameter, radius, chord, tangent, sector, and segment. We want to draw them on this circle. Now to do that, you're probably going to also need to draw a center on this circle. So I'm going to draw a dot in the center there. Now a diameter, if you have a ruler, please use it. A diameter goes from one side of the circle to the other side of the circle. It must go through the center. So let's draw that on there, diameter. We need to label them as well. So we've done the diameter. Next, the radius. A radius is from the center to the edge. So I'll draw a new one of those around here somewhere. So just from the center to the edge, that is called a radius. Okay, next word is a chord. The diameter is technically a chord, but we want to draw another one here as well. A chord goes from one side of the circle to the other. So that there would be a chord. And next word is a tangent. So a tangent is a bit of a funny one. It's a line that we draw that just comes and touches the edge of the circle. Oh, that's not close enough. Let me try that one again. Get my ruler a little bit closer. You just want it to come and touch the line just briefly. You don't want it to touch in 2 points. You can only touch at one dot here. And that is called a tangent. Next one is a sector. I actually already have a sector on my diagram. I just need to label it. A sector is like a piece of pizza. It is a 2 radii, remember that plural for radius, 2 radii that cut off a section of area there. That is called a sector. And the last word, segment, is the area that is cut off by a chord. So that part there is a segment. Okay, so you do need to know what all of those words are. Okay, moving down into the examples. It says use C equals 2 pi r, that was one of our circumference formulas, to find the circumference of the following circles correct to 1 decimal place. So for these first few questions, we're going to always be using that formula. When you do the working out for these questions, I want you to always start by writing the formula down. That tells me that you've identified the correct formula to use and that you're going to proceed hopefully correctly from there. So C equals 2 pi r, the formula, that's your first line. The second line is that we want to substitute in the radius that we've been given. Now notice in each of these questions, the reason we've chosen this formula is because each of these is a radius. They come from the center, go to the edge, center, go to edge, center, go to the edge. They're all questions that have a radius in them. So for this question, number 1, the radius is 3. So I'm going to substitute that into my formula. Now the 2 and the pi and the r, they are all multiplied together. We've just learnt about algebra. Things that are next to each other means that they are multiplied. So you can put multiplication signs in between each of them like that. As a shortcut though, you don't actually need the multiplication sign between the 2 and the pi because your calculator will do that for you. Okay, so let me show you on the calculator. We have 2 pi, remember to use the shift button, shift and then the times 10 down the bottom there. And then I want to times that by 3 because my radius was 3. And I want this to 1 decimal place, which means the 8 that's after, to the right of that decimal place, that's the one that I want to keep. After that, the critical digit is the 4, which will round down. So that means my answer will be 18.8. And my units are kilometers. So that's the answer. They're the 3 lines of working out that I want you to show, please. So let's practice that again for question 2. We know that we have a radius and we've been asked to use the formula C is equal to 2 pi r. The second line that you're going to do, now you don't have to keep writing the C underneath each time if you have your equal signs underneath each other. Okay, so I can just write equals here and then I can go 2 pi times by my radius, which is 10.2. Draw my equal sign underneath again and I have 2 pi times 10.2 and that equals, remember we want 1 decimal place, so the 0 is the 1 decimal place, but because my critical digit is an 8 I will need to round that 0 to be a 1, so it'll be 64.1 centimeters. Okay, let's do it again. Write the formula down. C equals 2 pi r. Keep the equal signs underneath each other and we're going to have 2 pi times by, the radius is this time 7. Type that in your calculator. 2 pi times by 7 is going to be 43.98. Okay, the 1 decimal place is the 9. The 8, the critical digit, wants to round that 9 up. Just to be difficult, that means it's going to have to bump it all the way up to be 44.0 centimeters. Because we round the 9 up, we have to actually round the number in front as well, making that 3 into a 4. Question 4. Start with the formula. C equals 2 pi r. Second line, substitute in that the radius is 9. So 2 pi, the radius is 9, so times 9. Third step, calculate. So 2 pi times by 9 equals 1 decimal place will be 56.5 because the 4 will round off. So 56.5. And that is centimeters. Okay, so that's the first formula. C equals 2 pi r. On the next page, we now have a new formula. It says use C is equal to pi d to find the circumference of the following circles to 1 decimal place. Now the reason we want this formula, we want the one with the d in it because d stands for diameter. When we go from one side of the circle to the other side, these are all now diameter questions. So we're going to use the C is equal to pi d formula. D for diameter. Okay, so like the last time, I want you to write down the 3 lines of working out. The first line is the formula, C equals pi d. The second line is going to be substituting in the diameter, which in this case is 22. So I'm going to have pi, remember there's a times in between, pi times 22. So in the calculator, pi times 22 is 69.1 to 1 decimal place. Question 2, let's do it again. C is equal to pi d is our formula. So the pi is times by the diameter, which is 20.4. Okay, type that in. 20.4. Oops, I start with the pi first. Pi times 20.4 is 64 point. Now for the 1 decimal place, I'm going to have to round that 8 up. So it's going to be 64.1 meters. Question 3. C is equal to pi d. This time the diameter is 20, so it's going to be pi times by 20. Third line in the calculator, pi times 20 is 62.8 because the 3 rounds down. 62.8 kilometers. And one more time, write the formula down first. C is equal to pi d. This time my diameter is 16.4. So pi times 16.4, and typing that in to 1 decimal place, we get 51.5 because the 2 rounds down. Meters. Okay, so in your questions to do today, you have exercise 3 of your work booklet. So you're starting on page 9, which will be using C is equal to 2 pi r for the whole page. Then page 10 will be using C is equal to pi d for the whole page. And then page 11 is mixing the 2 together. So you'll have to be able to identify, do I have the radius? Do I have the diameter? Which formula should I be using? All right, good luck. Do lots and lots of practice. Remember to check your answers.